Alright, so we're going to do worksheet 6A. We are going to look at some underhood sensors with this sheet. Some of it with the scan tool, some of it we're going to back probe with both the multimeter and with the scope. And you can see the actual scope pattern from some of our underhood sensors. So the first one we're going to start with is our throttle position sensor, then we're going to do our map sensor and our engine coolant temperature sensor. Alright, and then on the back side or the next page, we're going to do our crank sensor. Okay, as we can see here. Now, you have wiring diagrams for each of the different circuits included on your lab sheet. So what I want you to do is circle where I have back probed to get my signal. Okay, I'm not going to tell you which wire I'm in, and you're going to see the results of me back probing each wire, and you're going to fill in this information. All right, on this sheet based on what you see on the multimeter. Now, there's one question on here at the bottom. Using generic mode, obtain the temperature reading unplugged. That's not going to happen. Okay, it's easy enough in the lab, but on this vehicle, it's a heck of a lot of work to get down there to unplug it, so we're not going to do that. I'm just going to tell you right now what the result would be, and that would be minus 40 degrees Celsius unplugged. All right. You can see what it will be plugged in. I've got the scan tool hooked up, but I'm not going to unplug it. All right, so we're going to start with the throttle position sensor, and I'll get my camera person to zoom in on the meter reading. Okay, and we will start, and I will go through each of the wires, and you can see what the voltage is. All right, so key is on. All right, so key is in the run position. We should have. All right, so we are at basically 0 volts. All right, so there is another wire. We have 5 volts on that, so that would be our reference voltage. And our next wire, right now we are at closed throttle. We see 2.913 volts. All right, now when I accelerate this or open the throttle, we're going to see a change in voltage. Okay, so that is wide open throttle. 4.278 volts, that is closed throttle, 2.915. All right, so that's with a multimeter. So we can use a multimeter to check this sensor, although it's not the ideal way to do this. The ideal way would be with a scope. So we're going to connect the scope up now, and we're going to see what that looks like with the scope. Get my scope lead out. I'm going to connect this. I don't need the attenuator. This is a low voltage signal. This should be no more than 5 volts. It was just as we just saw, so I don't need the attenuator. So I'm going to unplug my meter, steal the alligator clip, and then maybe you could focus in on the screen, please, and I will connect this back up to my scope, to my back probe. All right, so we can see a voltage reading there, and I am going to accelerate my engine. Okay, so I'm opening and closing my throttle, and you can see the pattern here. Now, if this TPS was worn, we would see dropouts to ground. Okay, so we would see lines coming down from that peak right to ground. When you do this test, you want to snap it, and you want to look for any drops that go to ground, all right, or right to 0. They'll go actually below that line. That line is not at 0. All right, so this throttle position sensor looks to be working properly. Okay, it's a nice smooth transition, and I have no dropouts to ground. Okay, so each one of those peaks is me actually opening the throttle and then closing it again. Okay, so it's not making a voltage like a normal sensor would, it's making voltage as I open and close. So what we're looking at, of course, is the wiper sweeping over the resistor in the sensor with our 5-volt reference attached to it. Alright, so at closed throttle we are low voltage, of course. Wide open throttle, we're up near reference voltage. So that's our throttle position sensor. So our next sensor is our map sensor. So for our map sensor, okay, we're going to move our lead, and I'm going to go with the meter again for our first reading. So we'll go with the meter. I'll connect our alligator clip up to the meter. All right, and then we are going to, I don't want them to see which wire I'm in. They have to look it up. All right, so now I'm going to back probe on my map sensor. So my map sensor is located at the manifold here at the back. Okay, showing them where the map sensor is. There's our map sensor there, right here. Okay, so I'm going to get our signal off that. So we have 3 wires on our map sensor as well. All right, so let's look at our meter, see what we get. So we should have one, like just like our TPS, we'll have a ground. Okay, so that is in one of the wires. Okay, now this actually has 4 wires on it. They're not all TPS. One of them is for intake air temperature. Okay, so there is another 2.6. That is my reference voltage. And all right, so I have 3.949 right now. That's with pressure in my manifold. The engine's not running. I have atmospheric pressure in the manifold, so we can see we're near reference voltage. I'm going to start this vehicle right now, and we'll see what we have at idle. Okay, so we're at idle now. We have misfire as well, because I forgot to plug my injector in. Alright. So we are at 1.6 volts at idle. When I accelerate, I'm changing pressure in my manifold, so we can see the response from our sensor. Okay, so it should be an immediate response. There should be no lag. You can see that voltage reading, an indication that our map sensor is working correctly. So I'm going to go to my scope now, and we're going to look at what a map sensor looks like on the scope. So disconnect the meter, connect the scope up. Okay, so if you look at the scope screen now, we have a voltage reading there. So at idle, we are at about 1.8 volts. I can bring the cursor down, we can measure that in a minute. Okay, when I snap the throttle, right, we see a response. we see an immediate response. We don't see any dropouts. Now, let's stop this and back it up a little bit. Alright, so right here is what I'm talking about when I say dropout. So let's zoom in on that. So right here, this spike coming down is a slight dropout. Okay, we want to not have those. That's not good. That shouldn't be there. Okay, so a good map sensor should not have that. We're starting to have a map sensor here that's starting to have some issues. Alright, it looks like I got a lot of work to do on this car over the summer. This happens to be my daughter's car, who happens to be my camera person. So, anyways, we will address that at a later time. Alright, so that's what we're looking for. We also have one here that we can see right there. Okay, that is a dropout. That's to going to ground. We have a portion inside this sensor that is going to ground, and this is what we're seeing. That is not normal operation. Alright, so that is our map sensor. So that's our signal out of our map sensor. We're not going to get a signal out of the intake air temperature sensor. It's not part of your sheet. But we are going to look at the engine coolant temperature sensor, and we're going to do that next. Alright, so let me get out of here. Okay, so what we're going to do now wrong one, we'll go like that. Like that. So now we are looking at our engine coolant temperature sensor. Alright, so I'm going to reach down the back of the engine here, and we're going to clip onto our, I have a back probe in there already, so that's what we have right now. So right now our engine temperature, according to my scan tool, is 149 degrees Fahrenheit. It's kind of hard to get it focused here. And you can see it's up to 150 now. Okay, so my voltage at 150 degrees is 16.2, or 1.6, sorry, 1.62. Alright, so if we look at the two of them together here, this glare is awful. Alright, so we can see our voltage change with our temperature. If we can get this thing to focus, this is not good. Alright, so we're at 150 degrees, and actually we're at 156 now. This camera is not my friend today.
Jesus. Okay.
Alright, so we're at 158 and we're at 1.49 volts. Alright, so we can see our temperature, as our temperature changes, our voltage return to the PCM changes. Our resistance through this sensor changes. Okay, and it's going down, as you can see. Right, because what happens to our resistance with this sensor, as temperature goes up, resistance goes down, so our voltage is going down. Alright, we're up to 161 degrees Fahrenheit right now. A lot of glare here. 163, we're down to 1.4. So obviously this thermostat will open on this at around 195. And I don't know why we got so much glare here. This is brutal. Wow, that's bad. Sorry guys, this is really awkward. This very hard to see this screen.
It's not focusing on that because of that. Get rid of that. It's too bright for it.
Okay, we're at 167 and I'm at 1.3 volts. Okay, so we're just going to go 168, I'm down to 1.33. Not ideal, I get it. Just do the best you can with what you see on there and fill in your sheet. So we're at 170 and we're at 1.3 volts. Right, so our voltage is going down as our temperature goes up. So you can see the short-term fuel trim there toggling back and forth as well. And we're going to look at oxygen sensor in a few minutes, and we're going to see how the fuel trim corresponds. We'll look at the scan tool data, and we'll look at the scope, and we will look at the meter. So we're going to look at all three tools when we're doing that. So we're up to 172, we're down to 1.26 volts. Alright, so we're at 1.26 volts, getting down there as our temperature goes up. Generally, our cooling fans will come on at around 200 degrees Celsius, 201 to 204 in that area. Down to 1.228. Alright, so that's good. I'm not going to stand here until it opens the thermostat. We'll be here all day. Okay, so that's good enough for your sheet. Let's just look at what we've got to do here. Alright, so key on engine off. So we got it running. I will turn it off and you can see what these are. If testing with an ohmmeter, what would the reading be at the following? Well, we didn't do that with an ohmmeter. Just leave that blank, put NA in all three of those, don't worry about that. So key on engine running, you can see the signal voltage change. We can see the temperature on our scan tool data. We can see it change. Alright, so last we're going to look at crank sensor. And okay, so let me just take a look here. Crank sensor looks like it's kind of buried here. We'll take a look and see if we can get on that. Okay, we're going to end the video here. We'll come back with another